Okay, now it's time to put together motion in two dimensions and components of vectors. So I'm going to do the classic two-dimensional problem of firing a projectile over level ground. How far does it go? So the classic problem goes like this. You've got a nice level ground. Ooh, that's not that level. Sorry. Let's pretend it's level. And you fire a projectile at a certain angle. Now, we could fire it from a cannon. I'm going to kick a soccer ball, though, because I like kicking things. So, let's say, I'll keep it in black. Okay, let's say you kick a soccer ball, but when you kick it, you don't kick it straight to the right or straight up. You kind of kick it at an angle. So you're going to kick it so that its initial velocity, like this, is, say, 20 meters per second. You are probably like David Beckham or something, because 20 meters per second is really fast for a soccer ball. But when you kick it at an angle of, how about 30 degrees? 30 degrees. My question is, how far does it get before hitting the ground? So, the problem here is the ball moves both in the y direction, up and down, and in the x direction, left and right. But those two dimensions act separately, so I can't play with them at the same time. I have to separate them to get started. So that's the first thing we're going to do. The absolute first thing we're going to do. We're going to separate these things into the x component of v naught and the y component of v naught. So the initial velocity in the x direction and the initial velocity in the y direction. That's not too hard. This is what the component stuff was for. We're going to find the x component is the magnitude of initial velocity times the cosine of the angle it makes with the ground, or the x-axis. And the y component is the magnitude of the initial velocity times the sine of that angle. Okay, I'm actually going to leave those with no numbers in it for right now so that we can get a general equation in the end, and then we can go back and put the actual numbers in for this problem. So, well, if I want to know how far it goes, so how far does it go? That's a horizontal thing, so that's going to be an x. I'm going to call that range. Range. Okay, where the range that the ball goes is going to be how fast it was going in the x direction at the beginning times the time, because there's no acceleration in the x direction once you kick the ball. So that would be initial velocity in the x direction times time. So I've got this already, but time is a problem. I don't have time. How long is it actually traveling through the air? For that, I need to go look at the y stuff. So I'm going to say this is over here on the right hand side, I'm doing y stuff. Well, in y, what's basically happening is the ball goes up, it comes back down. So I'm going to put out my 6 things. I'm going to have initial position, initial velocity in the y direction, so I'm going to put a y on it, velocity in the y direction at time t, acceleration, this is in the y direction, so I'm going to put a little y on it as well, and time. So how long is it in the air? Well, it's in the air for the amount of time it takes to go from starting on the ground to coming back to the ground. Okay, where the initial velocity in the y direction is what we had over here in the blue. So v naught sine theta, like that. Vy is the velocity after time t, and I'm saying that time t is when this thing hits the ground again. I don't know what that is. I'm going to leave it alone. Acceleration in the y direction, well, the only thing that acts in the y direction is gravity, so I'm going to have negative, and I'm going to use 9.8 meters per second because WebAssign uses 9.8. Oh, excuse me, my throat is very sore. I think I'm getting sick. Time? I don't know time. I want time, though, so that I can then go and put it in there. So that's what I want. Put a question mark there. Okay, so I have I want something with t in it. I don't want anything with v in it. Not v naught, but v. The only equation that fits those two criteria is this one. Y equals y naught plus v naught in the y direction times t plus 1/2 at squared. Okay, this is the standard equation, most popular, I guess. Okay, now I've got y and y naught are both 0. I'm going to go ahead and put zeros in because it makes my algebra a little bit easier. Plus, well, v naught y, again, I'm not actually putting numbers in yet, but v naught y is v naught sine theta. So I'm going to go ahead and put that in too. V naught sine theta, and then times t, okay, plus, okay, 1/2 at squared. So 1/2, you know what? Instead of using a, I'm going to use g, and it's negative g t squared. Well, what I have here is I've got if I solve this for t is, well, it could be two answers. I can either do t is 0, so I can do, let's see, if I pull a t out, I get 0 equals t times, what's left over is v naught sine theta plus, well, I'm going to put negative g over 2 instead of 1/2 g because it's annoying. And then what's left is a t. So I could either have t is 0, which is true. At t equals 0, this was on the ground. That's the beginning of the problem. Or this stuff right here, let's see, this stuff, maybe that equals 0. Okay, so I could also say that 0 equals v naught sine theta minus g over 2 times t. Sorry, that's a little squished. Okay, so that's all well good. I could solve this for t and then plug it in over there, but you know what? I think it might be easier to solve this for t and plug it in over here. Yeah, let's try that. So if I go back over here, t, I divide this by v naught x. Come on, that's gone. So t is r over v naught x. Okay, I'm going to go ahead and plug that in right here. Now, unfortunately, this is going to be on the next page. Sorry about that. I'm going to go back to black. So I've got v naught sine theta. Come on, there it goes. So this is what I had before. Going to rewrite it. Minus g over 2. Go back. T, where t is r over v naught x instead. Like that. And now I'm going to solve for r. So I'm going to move this whole thing over to the left. So I'm basically adding this whole chunk onto the left-hand side. So I get g over 2 v naught x r, equals v naught sine theta. And you know what? At this point, just to get rid of the r, you multiply by the reciprocal of this stuff in the front. So what I get is r equals the stuff that was over there times this reciprocal. So 2v naught x over g, like that. And I'm going to go back and replace this v naught x with, back over here, v naught x was v naught cosine theta. Let's go back. Okay, so now r equals v naught sine theta times 2 v naught cosine theta. Sorry, that's a little sloppy. And that's all over g right now. Well, I got a v naught times another v naught, so r equals, and I'm going to pull that 2 out in front because typically you put constants out in front, coefficients. V naught squared. Then I've got this thing that says sine theta, and then I've got, ooh, sorry that's sloppy, cosine theta, and that's all over g. Okay, so you could use this, but we're going to do a little math trick here. You see this part here? Let's see. See this stuff right here? There's actually a trigonometric identity that says, see, I want to write it nearby. Okay, so the trigonometric identity says that sine, oops, no, oh, I'm sorry. I always do that. Put it back to full screen. I just wanted to change the color to match the highlighting. I'm sorry. Okay. The trigonometric identity says that sine times 2 times theta is equal to, oops, I forgot the 2. Oh, sine theta, cosine theta times 2. So I'm going to make, I want just this part though. So I'm going to divide by 2, both sides, and that goes away. Okay, so I can replace this section right here in the equation with this. Okay, so that gives me, got r equals 2v naught, okay, and then 1/2 sine of 2 theta, like that, and we're still over g. G is still there. Notice the 2 and the 1/2, they go away. So in the end, I get, for a projectile fired at an angle theta over level ground, the distance it goes before it hits the ground is v naught squared times sine of 2 times the angle all over g. This is called the range equation. It's well, it's pretty famous, but the problem is it only works over level ground. Why is my thing not working today? I'm sorry. It only works over level ground, and most of your problems are not over level ground.